whenever we are designing any particular application, that time, if we are going for the discrete components, then it will take a larger size, and so reduce the time, we go for the VLSI product. So that means we are going for the integrated circuit, and so the circuits which we can program as per our applications, that are called as a programmable logic devices. And then there are different types of this programmable logic devices. So that till now we have discussed that part. So let us revise that. So as we know that whatever is our logic, okay, so we can implement that using a standard logic. So that means we can use different ICs which are available in the market, and then we can customize our circuitry, or we can go for application specific IC. That means whatever is our design, our specification, depending on that we can design that IC. Okay, so these application specific ICs, these are, as we discussed earlier, these are of different types. That is the programmable logic devices, then gate arrays, cell based arrays, and full custom ICs. Okay, so these are the different types of ASICs. So first of all, let us again revise this programmable logic devices. Okay, so programmable logic devices, which are also called as a field programmable logic devices. So now this field programmable logic devices, these are again classified into three types. One is the uh, simple programmable logic devices, then complex programmable logic devices, and FPGAs, that means field programmable gate arrays. These are the three different types of programmable logic devices. Now, simple programmable logic devices is again classified into three types. That is a programmable array logic, then programmable logic array, and programmable read-only memory. Okay, so that is a PROM. So these are the different types of simple programmable logic devices, that is the SPLD. So here you can see the acronyms that we have used for each of this device. Okay, so CPLD, that means complex programmable logic device, FPGA, that means field programmable gate array, and ASIC, that means application specific IC. Okay, so now our focus is actually in this unit is on a CPLDs and FPGA, because we are not going to focus much on these simple programmable logic devices. We are uh, expecting knowledge about these complex programmable logic devices and FPGAs. So we have discussed in earlier lectures about some ICs which are commercially available, CPLDs and FPGAs. Okay, so but when we are going for this CPLDs and FPGA, we should have certain knowledge about simple programmable logic devices, and that is why we are going to discuss about these again, and then we will proceed for CPLDs as well as FPGAs. Okay, so what is mean by programmable logic devices? Kaustubh, what is mean by programmable logic devices? Yogesh? Yes. What is mean by programmable logic devices? Kaustubh, are you there?
Yes, ma'am.
Yes, what is mean by
Hello?
programmable logic device? Huh?
PLD.
PLD. Yes.
It is the device
What is use of
yeah. It is the device which in which we can program biologically, and for any work we can program logically. So it's called PLDs. Hello?
yes, yes. We can program. Yes, yes. We can program that device, and it is a logic design. So we call it as a programmable logic devices. Most of these ICs that we are using here, that are logic devices. So that means digital ICs that we are using. So here these are the programmable logic devices. So actually this programmable logic devices, it is a general purpose chip. Okay, so that means there are just a certain connections arrays of AND gate as well as OR gate, and depending on our specifications, that means user or customers specifications, it can be customized using certain programmable switches. Now there may be fuses in between the connections, so that by uh, burning that fuses we can make the connections, or make that connections open. So that is, or we can have SRAM based connection switch also. Okay, so in a FPGAs we have that type of switches. So but depending on our program, there will be connections in between the input of the gate. Okay, so that is a programmable logic devices, that is PLD. So there are main five types of this PLDs, that is a PLA, that is a programmable logic array, then programmable array logic, then ROM, that is a ROM, then CPLD and FPGA. So these are the different types of PLDs, and then system on chip. Okay, so that is the another aspect of this programmable logic device, where uh, it is a combination of standard cell as well as number of gates. Okay, so that means we can say it as a sea of gates, because there are so many number of gates in this system on chip, and that is the customized IC. That means it is depending on, again, user application. It is customized for number of application, number of logic functions that are built in a single IC. So that is a system on chip. Okay, so whole system that can be built on a single IC, that we call as a system on chip. Okay, so that is also again a programmable logic device. Okay, now depending on uh, how AND gate array and OR array is available in that PLD, we have different types. Okay, so in a programmable array logic, both AND array as well as OR array, that is programmable. Okay, so here you can see a diagram for a structure for this PLA, that is a programmable logic array. Okay, so here these are the input buffers and inverters, so that we can uh, have a input as well as invert of that, that means complement of that input that will be available with these inverters. So these inputs are available, so that means here IO switches that are available, and then there is a AND plane as well as OR plane. Okay, so we can program these connections so that we will have a product terms here. Okay, and these product terms that will be, that can be again programmed and given as an input to OR plane, and then we will get a output. Okay, so that is a programmable logic array. So remember that in a programmable logic array, that is a PLA, both AND array as well as OR array, these are programmable. So mostly this programmable logic array that is used for SOP form circuit. Okay, so where it is whenever the Boolean expression is in terms of sum of product form, then we are using this programmable logic array. Okay. So here it is a get level version of PLA. So here you can see that these are the inputs, and then there are certain inverters are used so that we can have uh, the input as it is, as well as it is in a inverted form. Okay, so that means in a complement form that we can get. So here we will get the input as a x1, and here it will be x1 bar, and then all these inputs that are connected through a programmable connection to this AND array. Okay, and then output of this AND gate that is connected to the OR gate through again programmable connections. That means depending on our program or our requirement, we can fuse these connections, and so we can get that input connected to the that AND gate, or we can remove that connection. Okay. So here, suppose we want to implement a function that is s1 is equal to x1 x2 plus x1 x3 dash plus x1 dash x2 x3 x2 dash x3. Okay. So if we want to implement, so first of all, what we need to do, we need to implement this product term using this AND array. Okay. So the first product term is x1 x2. That means here, as all these connections are initially intact there. Okay. इथले जे काही सगळे अँड गेटला कनेक्शन्स असणार आहेत ते आधी फ्यूज थ्रू कनेक्टेड असतील, पण ज्या वेळेस आपण प्रोग्रामिंग करू त्यावेळेस आपण काय करणार आहे, पर्टिक्युलर जे आपल्याला नको आहेत ते कनेक्शन आपण काय करणार आहे, बर्न करणार आहे, म्हणजे तिथलं कनेक्शन आपण रिमूव्ह करतो. ओके. सो that here we want just a connection to AND gate as a x1 and x2, so that will be kept and others will be removed. Okay, so here you can see x1 is now connected to this AND gate while x2 is also connected, all other connections that are removed. Similarly for other terms you can do this, and then you will get the product term, and then after that you can have a connection over here again in similar way for the OR plane also. Okay, and then you will get the actual output term. So this is the implementation of any function using a PLA. Now, what is the limitation of this PLA? Okay, so earlier we have not discussed this point. So today we are going to see that what are the limitations of this programmable logic arrays. One of is that programmable logic arrays that come in various sizes. Okay, so that means depending on the inputs as well as outputs, they comes in a various size, but typical size of this is there are 16 inputs and 32 product terms. Okay, so that means there are 32 AND gates that are used and 8 outputs, that means 8 OR gates that are used in a PLA. Okay, so this is the typical size of this PLA, that is a programmable logic array. Now that means, now here there are 16 inputs, that means how many input combinations will be there? If there are 16 inputs, that means 2 raised to 16 possible input combinations will be there. Okay. At the same time, for each of the AND gates, there is a if we increase the number of inputs, so each of the AND gate will have large spanning. So what is mean by spanning? That means it is the number of inputs that we are applying to particular gate. Okay, and fan out, that means number of outputs to the particular circuit. Okay, so here when we are increasing the number of inputs, आता इथे 16 inputs आहेत म्हणजे त्याचे परत इन्व्हर्टेड इनपुट असं मिळून 32 इनपुट्स एका अँड गेटला होतील. जर आपण अजून इनपुट्स वाढवले तर त्याच प्रमाणात आपलं काय होणार आहे, अँड गेटचे इनपुट्स वाढणार आहेत, म्हणजे त्याचा फॅन इन वाढणार आहे. ओके, अँड बिकॉज ऑफ दिस there will be certain limitations Okay, so we are not going in that much details about what are the drawbacks of if we are going to increase panel. So that we will discuss in some another session. But because of that, what happens? Actually, one of the drawback is that there is a delays that are created, and so that is the one drawback. And so we need to limit number of inputs then that can be provided in a programmable logic array. Okay, so that is the one case that we need to limit the number of inputs to the AND gate. Okay, at the same time, as we have 16 inputs, that means 2 raised to 16 possible input combinations will be there. But in a PLA, only 32 possible combinations that are permitted because we have only 32 AND gates. Okay, so in a typical size, we have 16 inputs and we have 32 product terms. That means we have uh, 32 AND gates, and that means we can just implement only 32 input combinations out of 2 raised to 16 possible input combinations in a typical PLA. Okay, so now uh, as here we have 32 AND terms that are permitted. So there is a large fan in for OR gate also. Okay, so that means there are large input that will be applied to OR gate as well, and this makes PLA slower, and then it makes that PLA expensive. Okay, so that is the main drawback, or when we can say it is the main limitation of PLA. Again, we have 8 outputs only. Okay, so in a typical size, we have 8 outputs. So we can it could have shared mean terms. Okay, whatever are the product terms, so that we need to share in proper way in a PLAs. Okay, so that is also one of the drawback of this PLA. Okay, so now we move towards the another type of PLD, that is a programmable logic array. Okay, sorry, programmable array logic. Okay, earlier we have said programmable logic array, in which there were programmable AND array as well as programmable OR array. Okay, now in a programmable array logic, that is a PAL, we similar to the PLA, here also we implement SOP form of circuits. Okay, so that means the circuits which are in the form of sum of product terms, so that we are implementing using PAL. Okay, but the difference between PLA and PAL is that in a PLA, both as well as OR array that were programmable, but in a PAL, only AND array, that means AND plane, that is programmable and OR plane is not programmable. ओके, म्हणजे तिथले तुम्ही फक्त AND arrayचे जे काही कनेक्शन्स आहेत तिथं प्रोग्रामिंग करू शकता, पण OR arrayचे जे काही कनेक्शन्स आहेत ते तसेच राहणार आहेत, तिथं तुम्ही काहीही चेंजेस करू शकत नाही. Whatever are the AND gate output, that will be connected to the OR gates only. Okay, so here this is the structure of this path where all the inputs that are programmable for the AND plane, but output of AND plane that will be a fixed connection for OR plane. Okay, so this is a programmable array logic. So here you can see this is the schematic of path using certain examples. Okay, so suppose I want to implement x1 is equal to x1 x2 x3 dash, that means x bar plus x1 bar x2 x3. Okay, so with this AND gate, first of all I need to implement this product term. So what I will do, I will program in such a way that I can get these product terms. Okay, so I need to connect x1, then x2 and x3 dash to this first AND gate. Okay, so that will be programmed. Then for the second AND gate, another term that will be programmed. But all these terms, okay, that are fixed to this OR gate. Okay, so there is no any programming between the this OR plane. Okay, so here addition of these two product terms that will give us the first function. Again, addition of these two product terms that will give us the second product term. Okay, so remember that in a programmable array logic, these product terms that we can program using programming for these interconnects. Okay, but here these are in a for a OR gate we cannot program it. They are fixed connections. Okay, so if we are comparing PALs with PLS, then PALs have same limitation as per PLS. Okay, that means small number of allowed AND terms, that is one limitation. Okay, plus they have a fixed OR plane. Okay, so this is another limitation of PALS. Okay, so programmable array logic is having one more limitation than that of PLA is that there is less flexibility. कारण आपण तिथं OR गेटचं प्रोग्रामिंग नाही करू शकत. जे काही कनेक्शन्स आहेत ते इंटॅक्ट राहणार आहेत, ते फिक्स राहणार आहेत. सो व्हॉट वी नीड टू डू, we need to program only at the end state, and therefore this is less flexible than that of PLS. But PLAs are simpler to manufacture and cheaper and faster. Okay, so this is the advantage of PALS over the PLS, and that is why this is mostly used in a PPLD. Okay, PALs have also often have extra circuitry connected to the output of each OR gate. Okay, now whenever we are going for the CPLD, that you will find that we can add certain extra circuitry to PALs, which we call it as a macro cell. Okay, and because of this we can get a maximum flexibility at the output. Okay, so that means we can implement the combinational circuitry as well as sequential circuitry by adding a macro cell. Okay, so that is the additional circuitry or extra circuitry that we are adding, and because of that we are getting a more flexibility for design. Okay, so this is the macro cell. Okay, now this we discussed while discussing Max 700. Okay, so that time actually this is the macro cell where output of a PAL. Okay, जे काही programmable array logic चा output आहे or gates, okay, that is connected to the flip flop. Okay, so D type flip flop, there it is connected, or it may be connected to the multiplexer directly. Okay, so there is a one multiplexer as well as one buffer that is used. Okay, and then output of flip flop and output from the OR gate that is connected to the multiplexer, and then output of this multiplexer that is connected to the buffer, and then we get the actual output. Okay, and this output that can be connected again to the AND plane, so that we can again program it. Okay, so this is about the macro cell which is present in the PLD. Now let us see how this macro cell that will function. Okay, so whenever this enable which is connected to the buffer that is 0, then what will it will do? It can be used to allow the output pin for F1 to be used as an additional input pin to PAL. Okay, so if this is 0, then we can use this pin as a input to PAL. Okay, so that means we can connect this to AND plane, and then we will get as an additional input, because actually in a PAL we have very limited inputs like a PLA. Okay, म्हणजे तिथे PLA मध्ये जसे 16 इनपुट्स आहेत तसेच आपल्या इथे फिक्स काहीतरी इनपुट्स असणार आहेत, आणि मग आपल्याला जर त्याच्यापेक्षा जास्त इनपुट्स हवे असतील तर आपल्याला काय करावं लागेल की नंबर ऑफ इनपुट्स हे इंटरनलीच फक्त वाढवावे लागतील आणि मग ते करण्यासाठी आपण काय करतो, जर ही इनेबल पिन जर 0 केली तर काय होईल की आपल्याला हे F1 जे काही कनेक्शन आहे दॅट वी कॅन यूज ॲज अ इनपुट टू PIL. ओके, so we can increase number of input pins. Okay, now if enable is equal to 1 and select is equal to 0. Okay, now if we are making this enable that is equal to 1 and if select is equal to 0, then this multiplexer will select whatever value that is available at this S0 input. Or A input, sorry, S not, we will say S0, it will be A input. Okay, so या इनपुटला जे काही अवेलेबल आहे ते ॲज अ आउटपुट म्हणून मिळेल या मल्टिप्लेक्सरचं. ओके, कधी मिळणार आहे, जेव्हा सिलेक्ट हे 0 असेल आणि एनेबल हे 1 असेल. एनेबल 0 असेल तर ही पिन काय होणार आहे, ॲज अ इनपुट पिन म्हणून कन्सिडर होईल. पण जर एनेबल 1 असेल तर इथं सिलेक्ट इनपुट प्रमाणे तुमचं इथलं जे काही इनपुट आहे ते मल्टिप्लेक्सरच्या आउटपुटला मिळेल. ओके, म्हणजे जर सिलेक्ट 0 आहे तर जे काही ऑर गेटचं आउटपुट आहे म्हणजे पाल्सचं आउटपुट आहे ते कुठं कनेक्ट होणार आहे, आउटपुटला मिळेल. ओके, पण जर सिलेक्ट 1 असेल, एनेबल पण 1 आहे, देन दिस विल synchronize the output changes with a clock pulse. Okay, so that means it will be now depending on the clock which is available here. So this output will get synchronized. Okay, so as we have here a flip flop, that is a D flip flop that is used, so this output will be available at the output of this flip flop as well as at this output of multiplexer depending on the clock pulses. Okay, so how clock is changing, in that way only output will change. Okay, now the feedback to the AND plane that provides multi-level design as here. Because of this feedback we can have a multi-level design in a that circuitry. Okay. So now okay, now what is mean by ROM? Okay, so we have not discussed it because it is a read only memory. Once we are going to program it, it will be remain same. Okay, so this ROM, okay, what is it? These are having a fixed AND plane and programmable OR plane. Okay, so these are the ROMs. Okay, so PLAs and ROMs are called as a SPLDs, which are simple programmable logic devices. These SPLDs that must be programmed so that the switches are in the correct places. Okay, so whatever are the switches between the interconnections that must be placed at a correct places, and for that certain CAD tools that are used. Okay, so first of all we need to program, and then after that we need to interface that device with the in such a way that we can get it fuse. Okay, so a fuse map is created by the CAD tool and then that map is downloaded to the device via a special programming unit. Okay, there are two types of programming technique. One is the removable socket on a PCB or in system programming on a PCB. Okay, so this is common. The in system programming is not very common for PLAs and PALs, but it is quite common. That means it is mostly in system programming that is used in a CPLD, while this fusing technique that is a removable socket. Okay, so that is used in a PALs and PLAs. Okay, that means a simple programming logic devices. In that we are using these techniques. So what is meant by in system programming? It is used when the logic device cannot be removed from the PCB. Okay? So once it is the program is done, or whenever this device is on a board itself. Okay, so that we call as a in-system programming. That is a ISP. Okay, a special cable and PCB connections that are required to program the SPLD from an attached computer. ओके, म्हणजे आपल्याला काय करायचंय, प्रोग्रामिंग करायचे. आता प्रोग्रामिंग करण्यासाठी आपण काय करणार आहे की आपला जो प्रोग्राम आहे तो आपण हार्डवेअर मध्ये डाउनलोड करणार आहे. ओके, आता हे करण्यासाठी आपल्याकडे दोन टेक्निक्स आहेत ॲज आय सेड अर्लियर, की एकतर आपण फ्यूज जे आहेत किंवा म्हणजे जे स्विचेस आहेत ते प्रॉपरली प्लेस करणार आहे, म्हणजे जिथे नको आहे तिथले आपण ऍक्च्युली काढून टाकतो. ऑलरेडी तिथे कनेक्शन असतं, पण आपल्याला नको आहे तिथले आपण कनेक्शन रिमूव्ह करतो. ओके, आणि दुसरी टेक्निक काय आहे की जेव्हा आपलं बोर्डवरतीच तो तुमचा आयसी आहे आणि त्यावेळेस आपण तिथले कनेक्शन रिमूव्ह करणार. ओके, सो याच्यासाठी आपण काय करतो की इन सिस्टीम प्रोग्रामिंग वापरतो. पण आता हे करण्यासाठी आपल्याला काय करावं लागेल की तुमचं जे काही किट आहे, म्हणजे जो तुमचा बोर्ड आहे ऍक्च्युअल तुम्ही जे इम्प्लिमेंट करताय ज्याच्यावरती, तो बोर्ड हा तुमच्या कम्प्युटरला कनेक्ट करावा लागेल आणि त्याच्यासाठी तुम्हाला स्पेशल केबल लागते. ओके, सो मोस्टली वी आर युझिंग JTAG कनेक्शन. ओके, सो IEEE 1149 standard that we are using for this type of connection, and this is very common approach to program for complex PLDs like CPLDs and FPGAs. Now let us see what is meant by CPLD. CPLD, that means a complex programmable logic devices. That is CPLD. Okay, CPLD as SPLDs that are limited in size due to small number of inputs and output pins. So there are limited number of product terms also. Okay, that is why we are going for the CPLD. Okay, CPLDs contain more circuit blocks on a single chip. Okay, so it contains number of PLs on a single chip, and so we can increase the number of inputs for that particular IC, and then we can implement a larger circuitry on a single IC. Okay, now why to go for CPLD? Though if we have a simple programming technique, so why to go for complex programming techniques? Because for a larger application, we need to require more inputs, okay, as well as more outputs. And we, if we are increasing that number of inputs in a SPLD, so what will happen? It will require a larger area, and if the larger chip area is required, that means it becomes costly. Okay, because if we are increasing, um, if there are n number of inputs, then n square much, म्हणजे आपण जर n number of inputs वाढवत असतो तर आपल्याला n square इतका chip area वाढवावा लागतो, and that becomes too costly. And again, gates become that logic gets slower as the number of inputs to AND gate array that increases, because there is a delay. As I said, if the fan-in increases, delay increases, and because of that, whatever is your logic, that will become slower. Okay, and so instead of using, or instead of increasing number of inputs to that particular SPLD increase, we can use multiple PLDs with a relatively small programmable interconnect. Okay, if we are using number of PLDs more, okay, so inputs required for that particular PLDs, that will be less, and then we can program these PLDs in such a way that whatever is your application, that can be implemented. So less general than a single design PLD, but we can use software to partition our design into smaller PLD blocks. Okay. So whatever is your application, you can partition it, you can make it in a simple block, and then you can design it that particular application. So that is a CPLD. Okay. Now, as I said earlier, because of the limitations of SPLD, we are going for the CPLD, and CPLD, that is nothing but a collection of PLDs and then interconnection between these PLDs on a same die or same chip. Yes. So there are more than 1,000 gates that are available in a single CPLD, and the vendors that are that means manufacturers for CPLDs, these are Altera, then Atmel, Cypress, Philips, Xilinx. These are some of the vendors for CPLD. So you can see Atmel, then HDL. These are some of the CPLD manufacturers. Then Altera. These are some of the CPLD manufacturers, and some of the CPLDs. These are Altera Max 7000, then Altera Max 9000, Altera Max 5000. It is also one family of CPLD. Then Atmel ATF and ATV. These are again CPLDs from Atmel. Then Lattice ISP LSI family, that is from Lattice. Then Lattice Vantage Match family. This is also again a CPLD family, and then Xilinx XT9500 family. Okay. So in this unit, we have discussed about Altera Max 7000 as well as Xilinx XT9500 family, and our interest is in these two families only. Okay. So we have not discussed, okay, and again we are not going to discuss about these families. We have just introduced what is CPLD and how it is there, or what is the architecture of these two CPLD in an earlier session. Okay, so that is about the CPLD. So this is about who makes or who manufactures CPLD. So these are certain manufacturers, then products, and then for your reference, their websites are also present here. Okay, so if you want, you can go to all these websites and you can check what are the differences between all these commercially available devices. Okay, you can download their data sheets from their site, आणि त्याच्यानंतर तुम्ही बघू शकता की प्रत्येक याच्यामध्ये डिफरन्स काय आहे, प्रत्येकाचे प्लस पॉईंट काय आहेत, मायनस काय आहेत, आणि त्याच्यावरून तुम्ही डिसाईड करू शकता की आपल्याला कुठला CPLD चूज करायचा आहे, आपल्याला कुठला जास्त इफिशियंटली आपल्या ऍप्लिकेशनसाठी वर्क होऊ शकतो. दॅट यू कॅन डिसाईड इन युअर particular application. Okay, so that is about the CPLD. So here this is the block diagram of CPLD. Generally almost all CPLDs will have this type of blocks. Okay, so there is a PLD, multiple PLDs that will be present on the chip. Okay, so these are here these 6 PLDs that are shown. Okay, it may be of a PAL type or it is a PLA. Okay, so that may be there, but as the loss, as I said earlier, cost of PL that is less as compared to PLA. So mostly these are of a PAL type. Okay, but not necessarily it should be PAL. It may be PLA. Okay. Then there are programmable interconnects which will connect these PLDs with each other, as well as it will connect these PLDs with the IO blocks. Okay, so these are the IO blocks which are present at the outside. Okay, so these may be present on the periphery of your chip. IO blocks that will be present on the periphery, so that you can have input as well as output pins that will be connected at the that chip. So again, this is a structure of CPLD. There is a PAL-like block that will be present. Then there will be interconnection wires which will connect these blocks, PLD blocks, to the another PLD block, or it may be used to connect IO blocks to the PLD. Okay, so these are the input output blocks that are present. So this can be directly connected to the PL block, that is the PLD block, or it may be connected to the PAL through this interconnection wire. Okay, so here now this PAL block that we can program at that level, or again we can program at this interconnection level. Okay, so and again as we have number of PAL blocks that are present, so we have more flexibility for the programming, and larger application can be implemented using this CPLD. Okay. So if we look for the internal structure of this PLD, that is a PAL-like block, okay, it includes macro cells, okay, and usually these are about 16 each. Okay, so प्रत्येक PLD मध्ये minimum 16 macro cells that are available. Then there are fixed or planes, and these are OR gates which is having fan-in. That means number of inputs in between 5 to 20. Okay, and then there are also XOR gates that are provided to provide negation ability. That means to get the inversion, there are certain XOR gates that are also present. Okay, then macro cells, as we discussed earlier now, so that are also present, so that we can implement combinational circuitry as well as sequential circuitry. So this is the detailed architecture of CPLD. Actually, we have discussed this architecture related with MAC 7000 series as well as Xilinx XT 9500. Okay, but you must have observed that in both of these ICs, almost the structure is similar. Okay, maybe there is a slight difference, but almost it is same. So this is a like it is a PAL-like structure, that is a PLD, which is having macro cells which are connected to this IO block. Okay, then there is the interconnect array. So these macro cells output that can be connected to the interconnect array, or whatever is the input that is present at the interconnect array that could be connected to this PAL structure. Okay, or a PLA structure. So here this will form one SPLD block, that is the IO unit, and this part that will form one SPLD block, and this is another SPLD block, and these two blocks are connected with each other through the interconnect array. So this is the CPLD block diagram. So here, as again, these are the functional blocks. That means logic devices that are present, then interconnect matrix, and then IO blocks. Okay, so IO blocks, that means this where we have the inputs as well as outputs. So these inputs that will be connected to the functional block, or whatever is the output from the functional block, that could be given to this IO block. Okay, म्हणजे ते तिथे तुमचे काय असेल that you can program as the input pin, or it could be implemented as a output pin. Okay, now these functional blocks that are connected to the interconnection matrix, depending on the requirement. Okay, so there you can do a programming, and out from this interconnection matrix it could be given to another logic circuitry, that is a PLA block, or it could be connected to the IO block. Okay, so now here whatever is this program interconnect matrix, that will have a programmable switch for interconnection. Okay, so this is output
Yes, ma'am. Hello.
Kaustubh,
Yes, ma'am.
am I audible?
Yes.
माझा आवाज
Now
ब्रेक
it is
होतो का?
audible.
ओके
Hmm.
ओके ओके ठीक आहे. Then if it is
Okay.
there is a problem, we will okay. So you okay, we will meet the next session at 3.